Okay, sorry, I got interrupted by a bunch of people there. Hopefully the noise didn't bother you too much. So let's try a different example. It's um, it's really a lot easier than what that question made it look. Just because there was fill in the blanks, it was kind of annoying to really explain it in the most basic way. So what I want to do is I want to go through this word problem here, but I really just want to emphasize the simplest way to solve this. So the question says, caribou jerky, a traditional Inuit food, can be seen drying on wooden racks along the shores of the Arctic Ocean. A piece of wood 2.8 meters long that could be used to build a drying rack rests against a wall. The angle between the piece of wood and the ground is 40 degrees. So we need to make a rough sketch, bearing in mind that we are dealing with triangles in this unit. So if this is your ground and this is your wall, your piece of wood is leaning up against the wall. And we know that the piece of wood is 2.8 meters. And the angle between the piece of wood and the ground is 40 degrees. So we can just rewrite that triangle if you want to be something like this, where that angle is 40 degrees and this side is 2.8. Now they want to know the distance between the bottom of the piece of wood, which is right here, and the bottom of the wall. So we're looking for that side length right there. So now we want to label this triangle. So step one, label your triangle. So the side across from my known angle is the opposite. The side across from the right angle is the hypotenuse, and the side between the right angle and the known angle is the adjacent. So step one, label your triangle. Step two, figure out which ratio we're going to use. So if you do your SOHCAHTOA, we have to figure out, are we using sine, are we using cos, or are we using tan? So the way to do that is look at what side length you know and what side length you're looking for. So we know the hypotenuse and we're looking for the adjacent. So if we go to our ratio here, we have one that uses adjacent and hypotenuse, and that's the cos ratio. So we're going to have cos of our angle is equal to adjacent over hypotenuse. And now what we can do is fill in the numbers, right? So we have an angle here and then two side lengths. So there's three pieces of information in this equation, and we need to know two of them to solve for the third one. So let's fill in what we know. Cos of 40 is equal to, we don't know the adjacent yet, so we're going to leave it as x over 2.8. Okay, so this is the part where I think everything got confused last time. I was kind of crammed in on the side of my page and people were walking around my classroom. When you get here, we are trying to solve for that variable. And when we solve for a variable, we want to get it by itself, right? This is algebra. We want to get that by itself. This cos 40 right here, this has a value. It's like a number. It's like its own term. So just leave it alone for right now. And in order to get x by itself, we need to get rid of this 2.8. It's being divided, that x is being divided by 2.8. So in order to get rid of it, we have to do the opposite. We have to multiply both sides by 2.8. Because in algebra, what you do to one side, you have to do to the other side. Because now, on the right side of our equation, when I do algebra, I like to do a little dotted line all the way down. On the right side of the equation, I have 2.8 divided by 2.8, and that ends up canceling down to 1. So we get rid of that, and we're left with x. On the left side of the equation, we still have 2.8 multiplied by cos of 40. So all I'm going to do to solve for x now is punch in my calculator, 2.8 multiply, hit your cos button, and then it'll come up like that, cos, and then you type in 40. And when you do that, x should equal, if you type that in, x should equal 2.1 meters. And so a good way to check to make sure you're doing things right is the longest side of the triangle should always be the hypotenuse. So 2.8 should always be the longest side. So if this x came out to be 3, something probably went wrong. It didn't. It came out to be 2.1, so that's perfect. Meters. Make sure your calculator is in degrees. If you see at the top of your calculator rad or an R or even grad, then you're not going to calculate the right ratio. We'll go over that in class, but I just wanted to double check. If you're typing this in your calculator and you're getting things wrong, it's because your calculator's in radians and not in degrees. Okay, I want to go over a couple more examples. I'm going to skip the next one, and we'll roll on to this one right here. So now what we're going to do is it's going to be a little bit different. We're going to set it up the exact same. So let's look at our triangle before we get into any of the fill in the blanks. The angle that we know is right here. It's 64 degrees. So we can label the triangle. The angle opposite of the side opposite of our known angle is the opposite. The side opposite of the 90-degree angle is the hypotenuse. And the side between the two angles is the adjacent. It's important that you get that right every time because you're going to start using the wrong ratios if you get that wrong. Okay, so now in order to determine the ratio that we want to use, I'll try to write it a couple different ways. We need to figure out what side length we're looking for and what side length we have. So we have the adjacent and we're looking for the hypotenuse. So what ratio uses adjacent and hypotenuse? There's only one of them. So look through, and you're right, it's this one right here. The cosine ratio, it uses adjacent and hypotenuse. So we can set that up as cos of our angle. Cos of 64 is equal to adjacent over hypotenuse. That's adjacent over hypotenuse. And so they've already filled it in here. 7.9 is our adjacent divided by A. So in the first two questions, the unknown, the variable that we were dealing with, sorry, I'm just going to erase this. The variable that we were trying to find was in the top of that fraction. Now, the variable that we're trying to find is in the bottom. So 2 steps need to happen in order to get A by itself. Because in order to solve this, we need to get A by itself. So the first step is to get A into the top of the equation. Right now it's in the bottom of a fraction. So what you can do is multiply both sides by A. And it ends up canceling this A on this side. But now we have our A on the opposite side and it's in the top. So what we're left with now is A multiplied by cos of 64. Cos of 64 is still its own term. Now what you want to do is you want to get A by itself. So you can divide both sides by cos of 64 because cos of 64 divided by cos of 64 cancels out. And what you're left with is A is equal to, because we've canceled everything else out on the left side, 7.9 divided by cos 64. So in your calculator, you can go in and type 7.9 divided by cos 64. Make sure you are in degrees. And when you do that, you should get, and then hit enter or equals, you should get 18. So that means our hypotenuse is 18. And that makes sense because it should be the biggest side, and 18 is bigger than 7.9. Hooray! Let's do one more example. Determine to 1 decimal place the length of the hypotenuse of triangle PQR. So first of all, we're dealing with a triangle, so I'm going to draw my triangle. Not the best. So we have to label it properly. It says angle PQR is 90. That means when I move from P to Q to R, the angles should make 90. So if I go, so this is my 90 right here. So if I go from P to Q to R, that gives me a 90-degree angle, right? Because I go from P to Q and up to R. And the next angle they tell us is angle PRQ is 28 degrees. So from P to R to Q means that's going to be that angle right there. It's going to be 28 degrees. And then the last piece of information they give us is side length PQ is 15.6 millimeters. So 15.6 millimeters on that side. And they want us to find the length of the hypotenuse, which is right here. So the first thing I want to do is label the triangle. The side opposite from my known angle is the opposite. I've already labeled my hypotenuse, which is the side across from the 90 degree, and my adjacent, which is the side between the known angle and the right angle. Now I need to, if I'm looking for the hypotenuse, maybe I'll put an X there. I am looking for a trigonometric ratio that is going to use opposite and hypotenuse because I have the opposite and I'm looking for the hypotenuse. And that ends up being the sine ratio. Sine of X is opposite over hypotenuse. So now I can fill out what I know. Sine of my known angle, 28. And now I'm equal to opposite, which is 15.6 over X. So now I need to solve for X. The hardest part is setting up the equation. A lot of mistakes happen there, so please take your time, label your triangle, write down your ratio first, and then fill in the information. Now we need to get X by itself. So what I can do is multiply both sides by X to get that into the top of the formula. Cancels out on that side. I'm left with X multiplied by sine of 28, and that's equal to 15.6. Now I can divide both sides by sine 28. I really want to get this X by itself. So in order to do that, I need to divide out a sine 28 from both sides. And what I'm left with on the left side of the equation, because that cancels out, I'm left with X. Let's do it down here. We're not going to do that question anyways. And on the right side of the equation, I have 15.6 over sine 28. So I can punch that into my calculator. 15.6 divided by sine function 28, close the bracket, equals, and when you do that, you get 33.2. And we started in millimeters, so we end in millimeters. That means the hypotenuse is 33.2 millimeters. Does that make sense? Yeah, it's the hypotenuse. It should be larger than the side length I started with, and it is. So it makes sense. That's it. We are going to keep practicing. So thank you for watching.